Hi, eighth graders and eighth period specifically. Happy Wednesday. We are halfway through the week and we are getting closer and closer to spring break. So, you guys are doing a great job. I know I tell you all the time, but I'm just very happy and I'm very proud of you guys. So, a few more lessons and then you are on spring break quarantine mode. All right, today we're going to push forward with chapter 7. We're going to go more into the properties that involve multiplying with powers with the same base. Um, just to make sure we're on the same page, all you guys are doing the rest of this week is just simplifying exponent expressions. So you're just using the rules and the properties that we look at, and you're just simplifying different expressions that you're given. Something that would be helpful for you, especially today and tomorrow. Okay, I'm being very serious. Get yourself paper, get yourself pencil, write down some of the examples so when you're working on your assignment, it's going to make your life easier, especially for this one component of the lesson today because you've never seen anything like this before. It is so important that you are listening to my explanations for the processes for the simplification and that you're watching what I'm doing with my virtual pen and my highlighter. Okay, it's very important. So let's go ahead, let's get started. These two problems are a quick review from yesterday's lesson. So if you were with me in class right now, I'd say, all right, let's do a quick review. Let's jump in. So right now, pause the video. You guys try those two expressions and then see what you get. All right, so looking at this expression here, I see two components that I know that I can simplify. Two that kind of stand out to me. Right now, I see that I've got y to the negative 2 power, y to the negative second power. You cannot have negative exponents. We need to change those into positive. So knowing that they're technically in the numerator right now, I know that that term needs to move to the denominator. And when I do that, it will become positive here. So I saw that the y had the negative 2 power. Just move it below and it becomes positive. And then there's one more step too, and hopefully you can see this. If I have 2 to the third power, I know what 2 to the third power is. I know that 2 times 2 times 2 is 8. So you can simplify that, and now you just have a coefficient for your term. And so it's just 8x cubed over y squared. For number 2, for our second review problem, I see that I've got r to the negative 4 power and I've got s to the negative 2 power. The only thing that I can do to simplify that expression is take both terms and move them to the denominator, and then their exponents become positive. Notice that your 2 and your x will stay right where they are because they don't need to do anything. They don't need to be simplified. So this is what it would look like. These two pieces in the green would just come to your denominator. Their exponents become positive. Your 2 and your x stay in your numerator. That is review from yesterday. Let's move forward. So here we go. If I asked you to expand this expression, what would it look like if you wrote this out? Okay, so if I had 3 cubed times 3 to the 4th, to me, if I expanded that, that would look like, all right, I've got 3 times 3 times 3. That takes care of my 3 cubed times 3 times 3 times 3 times 3. Now, that's pretty much doing the most, especially for our honors class here. We can consolidate that expression by making a generalization here. Notice that it's the same number being multiplied several times. That means that our base will stay as a 3 here. And then you need to ask yourself, well, how many times did we multiply it? And if I counted these up, I would say, all right, we multiplied it 7 times. So you can now generalize. And again, hopefully this is a little bit of review. If you are multiplying terms that have the same base, 3 and 3, all you need to do is add their exponents. So if I saw that I've got 3 cubed times 3 to the 4th, I know I can keep my base of 3 and then just add 3 plus 4, which would give me 7. Okay, so this is property number 1. If you're generalizing, here's what it would look like. All right, if I've got a to the m times a to the n, that's just going to stay with my base of a that shows up right here, and then you would just add m plus n together. Okay, now let's put numbers with it so we can kind of bring some more life to it. So notice that I have 9, 9, and 9. That means that 9 is my base, and it's going to stay as my base. And then because we're just multiplying, you're just going to add these all together. So negative 3 plus 2 is negative 1. Negative 1 plus 6 is 5. So if I simplified this, it would just be 9 to the 5th power. Keep your base, add your exponents. This one, you're going to take two or three steps to simplify depending on how your brain's kind of working. Right now, what I see right away, I see that number one, these are being multiplied because you've got two parentheses stuck to each other. If you don't see addition, division, subtraction, we're assuming it's multiplication. So I know I can actually multiply these coefficients together right away. So I've got 4 times 9, which is 36. I also know that because I'm multiplying powers with the same base, because I've got z here and I've got z here, I can add their exponents. So 5 plus negative 12 is negative 7. So here's what I've got so far, you guys. I've got 36, because 4 times 9 is 36. And I've got z to the negative 7 power, because 5 plus negative 12 is negative 7. Now, knowing our properties from yesterday, this right here should stand out to you, okay? We can't have those negative exponents. So all you need to do is take z to the negative second and send it down below, and then it would just look like this. So notice how we went from something that looked like a lot, but once you kind of broke it out in the different steps, it's not as complicated as it looks. All right, here's one more before we move on to the next property. Again, there's a lot going on right now. There is. So let's start with what we know. So I know that there's a 1 in front of the a. I don't know if that helps us any. And I also know that these are being multiplied here. So if I say, all right, what is 2 times negative 11? I know that that's negative. Oh, wow. Yikes. We'll just type it out. I know that 2 times negative 11 is negative 22. That's what I know. The next thing, I see I've got a, and I've got a. That means that I'm going to keep my base of a and add all of my exponents together because we're technically multiplying. So even though we don't write it out for ourselves, we know that this little guy has an exponent of 1. So 1 plus 2 is 3. 3 plus negative 3, that's a 0 pair, so they cancel out, so it turns out to be 0. But ask yourself, do you need a to the 0 power? You don't, because that's just 1, and we talked about that yesterday. So technically, we can just get rid of this whole piece here, and your simplified expression would literally just become negative 22. And then you're done. All right, moving on. Now, this is what looks a little bit different, and listen to my verbiage on this one. So for property number 2, notice that you've got x to the 5th to the 2nd. You've got x to the 5th to the 2nd. When you've got a base with an exponent that's also raised to a power, we are now going to be multiplying your exponents together. Okay, so you would have x to the, what is 5 times 2? And then you're going to tell me that it is 10, and I'll move this in 1 second. And it would look like this. The reason why you're multiplying them, because if you've got x to the 5th squared, that's like saying that you've got x to the 5th. Now let's see if I can write this in a nice way. You've got x to the 5th power times x to the 5th power, because it's squared. It's x to the 5th times x to the 5th. We know from the property we just looked at, if you've got x to the 5th times x to the 5th, we just have to add those, and that becomes x to the 10th. But we don't need to do all of that work because we can generalize a rule like this and come up with something more concise and something simpler. So to generalize, if we have a to the m to the n, that's the same thing as saying a to the m times n power. Okay, when you see something like this, you are going to multiply your exponents together. So we are multiplying these. Now let's start simple and work our way up. If I've got 5 squared to the 3rd power, again, I see that I've got these two exponents here. I know that I'm going to need to multiply them. So keep your base of 5, and then ask yourself, what is 2 times 3? And you would tell me that it's 6. So your simplified version is just 5 to the 6th power. This has a few properties combined into one. Not that tough, but you do need to know how to kind of simplify this out for yourself. So here's what I would do. Let's start with this right here. Let's do these right here. If I've got y to the 5 over 2, remember 5 over 2 is the same thing as saying 2.5, or you can also even write it out like this. And actually this might even be easier. So you've got 5 over 2. and then to the negative 2 power. I know that I'm going to be multiplying these together. So what if I set it up like this? So now I've got y to the 5 over 2 times negative 2 over 1. If I simplify that, I still have my base of y. I know that 5 times negative 2 is negative 10. And then if I multiply my denominators here, I've got 2. Now we can actually simplify that right now. What is negative 10 divided by 2? And then you're going to tell me that it's y to the now negative 5th power. So you guys, here's what we did. First of all, we're like, let's do this part of the expression first. I know 5 over 2 times negative 2 over 1. 5 times negative 2 is negative 10. 2 times 1 is 2. You can simplify negative 10 over 2 to negative 5. So now let's go ahead and get rid of all of this to make our lives easier. Okay, so the only other part of the expression that we now need to take care of is this y to the 3rd down here. And so here's what it looks like within our expression. We now have y to the 3rd times y to the negative 5th. Again, you guys, this is just going back to the property that we looked at first. You got 2 bases, 2 exponents, keep your base of y, and let's add these together. What is 3 plus negative 5? And hopefully you're telling me negative 2. Last step. If you've got y to the negative 2 power, we can't leave it with the negative exponent. So we are just going to bring it down to your denominator, and then it becomes positive. So if this was a lot to watch, rewind this whole thing, rewatch it again, and go through the steps together. All right, almost done. This is the part where you have to write this out as an example for yourself. Okay, so here we go. Let's say that I give you 8 to the 2/3 power. 8 to the 2/3 power. How in the world can you set that up? This is my quick trick for you. You are going to set up 2 things. First of all, you're going to set up a type of root, whether it's square root, cube root, 4th root, and then you're going to also have an exponent with it. To know what type of root that you're going to use, it's the denominator. Okay, and then your numerator of the fraction tells you the exponent for the expression. So watch how I set this up, and then it'll make more sense. So you're going to start by rewriting your base number of 8. Okay, then to know what type of root it is, look at my denominator. So because this says 3, I know, oh, okay, this is going to be a cube root. Then ask yourself, all right, which type of exponent is going to be used for the expression? And it says my numerator, so I should have an exponent of 2. Then to simplify, what is a cube root of 8? Okay, and hopefully you're telling me 2, because 2 times 2 times 2 is 8. And then we keep our exponent of 2. And what is 2 squared? Hold on one second. What is 2 squared? It is 4. Let me show you that again. So when you're given a base with an exponent that's a fraction, you need to set up a root, and you need to set up a special exponent for it. So to know what type of root, we are going to look at the denominator of that fraction. So if I'm looking at this, I'm going to retype out my 16, nice and big. And I know that because it's a denominator of 2, that it's going to be a square root. So this is just going to be a regular square root. Even if you put an index here of 2, it doesn't really matter. The numerator is the exponent for the expression. So this expression here would have an exponent of 3. Now when I'm simplifying, what is the square root of 16? And you would tell me 4. And then you need to take that to the 3rd power. So you'd say, all right, 4 times 4 times 4, which gives you 64. All right, so that is everything for today. I know that was a lot of information in one video, especially with this last part here. But if you need to rewatch it, especially, you might even want to take a picture of this screen right here. That will be helpful for you. Your assignment today is 7-2 Wednesday lesson quiz. It says 32520 online Pearson. There are not that many questions because you're focusing on accuracy. Accuracy is your goal. And problem solving number 4 is due by 11:59 tomorrow night. So I think that that's all. You guys have a wonderful day. If you have questions, message me. Thank you for tuning in. See ya.